Okay, so we got problem 7.36. The switch in the circuit has been in position A for a long time. At time equals 0, the switch moves. So let's go ahead and draw this circuit. What the first circuit looks like at time before or less than 0. We know that the inductor acts as a wire. Okay, so we got 10, 40, yeah, oh, and the 800 volts. Yeah. Notice IS, I1, I2, oh, we can call instead of I2, and say it's I naught. Okay, then we can go ahead, do our KCL. IS equals I1 plus I naught. Equation for components. 800 1 over 120. I1 equals V1 over 40 is equal to V1 over 10. So we have 4 equations, right? So yeah, IS equals I1 plus I naught. IS equals 800 minus V1 over 120. I1 equals V1 over 40. I naught equals V1 over 10. We got I1, IS, I naught, V1. Okay. So I naught time. Just emphasize that. And then V1 would be our V naught at 50. Okay, it would be 50 volts. V naught before or right before 0 would be 50 volts. Okay. So now we can go ahead and move on for t greater than 0. We can do a source conversion. So E equals IR. We can say 50 times 8 is 400. So you can make this a battery instead, or a voltage source. So I'm going to say 400 and then 8 ohms. 10. And then we're going to find the voltage across this inductor. Essentially, the reason why we want to find the voltage across this inductor is because it will facilitate us to find the current at time infinity across this component. So yeah, yeah, here. So we're gonna follow. Oh, I forgot to draw this. $40 ohms. Okay. Circuit analysis, 500, C1, T. Oh. We got I1 here, and I1 is going to keep flowing here, right? And yeah. Yeah. So here we see that I1 equals 400 minus V1 over 8 equals V1 over 440, right? So we can do the math. 1 divided by 8 is 5. 2000 minus 5 V1 over 1 V1 over 2000 over 6 is going to be 333.3333. Okay. Then of this we can find our R equivalent, right? So just go ahead and say this. Eight, 40, 10. So our equivalent is plus 10, which is 16.6666, 16.67 ohms, right? So so then or yeah. So our next step would be to put this equivalent here, voltage equivalent. So we have V1, V1, V naught. So these 333.33 volts, 16.67 ohms. Then we have the inductor. And we have, what's the inductor again? 40 millihenry. Okay. Current I naught, right? Yeah. Yeah, so make this bottom ground. Right, so this is 333.33 volts. It's gonna be our V1. Okay. Since we already have an R equivalent and we have our inductance, we can find our tau, right? Tau is L equivalent over R equivalent. So then 48 e to the -3 over 16.67 is going to be equal to 0.0024. Okay. So then our current, yeah, this is all for our current. Yes, current I naught is going to be equal to 333.33 over 16.67. And that's going to approach, it's going to be 19.99. So it's going to approach 20. So I'm going to call it 20 amps instead. The decimals here definitely mess up something inside. It definitely approaches 20 if we add more decimals. But anyways, so you know that for, so I naught time infinity is 20 amps, right? And you know that I naught at 0 is equal to 5 amps. So off this, we're able to formulate an equation for I naught. All right, so 25 minus 20 e to the negative t over 0.0024. Uh, 1 over 0.0024 be, okay, it's gonna be like negative 416.67 t, right? So that's gonna be our I naught for t greater than 0, and for our v naught, we, well, this is part A. And for part B, we know that B is equal to L times di t over dt. For this case, it'd be I naught, derivative of I naught. So you know that d t dt equals to negative 416.67 times 15 times yeah, times negative 15 e to the negative 4 is, oops. I should probably erase this. It looks like a 7. And yeah, this, yeah. I'm just gonna leave it like that. So then we know that, I guess, we know that V naught at time 0 is 50. Right. So V naught. Yeah, so we can say 40 to negative 3 times yeah. 4, 6, 16, 7. Right. Not. So just make sure. Yeah, so V naught is it's going to be the sum of the functions of these two. So 10 times and yeah, so this V naught for t greater than 0. This would essentially everything highlighted here plus this is going to be our function of V naught for a time greater than 0. And is there anything else missing? No. Yeah. That'd be it. It's a long number.